All right, so let's look at an example of how to do this hypothesis testing, and this will be kind of just from start to finish, step by step, and we'll see. This is not super complicated, and I think if you follow these steps, then it is actually very easy. So we're on page 4 in the chapter 18 notes. And so this one says the DMV claims 80% of all drivers pass the driving test. In a survey of 90 teens, only 61 pass. Is there evidence that the pass rates are below 80%? And so we're going to break this down into 6 steps, I think. So step 1 is state the hypotheses. And so we need a null hypothesis. We need an alternative hypothesis. And so we said in the first video in this chapter, the null hypothesis is basically that nothing has changed. And so this is a categorical variable. We can see this percents a lot of times indicate that we're talking about a categorical variable. But we can also observe that you either pass the test or you don't. So we have 2 categories, pass and not pass. So this is a categorical variable. So we are going to have our parameter is P, and the null hypothesis is always equals. So what does P equal? So if you're reading this problem, what would the population proportion be? And it would be 0.8 or 80%. And then the alternative is always going to use the same parameter. So if this is P, this is going to be P. They're not going to change. And it's also going to use the same number. Now, the only thing that changes is this is not going to be equal. It's going to be either less than or greater than or not equal. And since we're looking at below 80%, it is going to be less than. So our null hypothesis is that P is equal to 0.80, and our alternative is that maybe it's below 80. So now that leads us to step 2. Step 2, we're going to check conditions. And if you remember, our conditions are independence. And we can assume independence because probably one teen passing is not going to affect another random teen passing the driver's test. So this one should be good. Condition 2, 10% condition. Our sample size should be less than 10% of the population. This is our sample size N. So 90 teens would be less than 10% of all teens. So that one is good. And usually these 2 are going to be met, especially this one. I don't know. It's really hard to definitively say that one's not met. And then step 3, the success failure condition. So this one says we should have at least 10 successes and at least 10 failures. I've seen both ways of this. So either we actually have 10 successes and 10 failures, or we should expect 10 successes and 10 failures. Either way, they're probably, if one's met, probably the other one's met too. But we can just see if n times p is greater than 10 and see if n times q is greater than 10. So that is our p. So we have 90 times 0.8, that would be 72, and that is greater than 10. And then we have 90, q would be 0.2, so q is 1 minus p, and that would be 18. That is also greater than 10. Or if you used how many successes do we actually have? In this case, we have 61 actual successes. That's more than 10. That would leave 29. So 90 minus 61, that'd leave 29 that are not. So either way, that condition is met. All right, step 3. And this is kind of where really getting into solving this problem. This one gets you started. This one, yeah, it gets pretty easy to do after you do it a few times. Step 3, we are going to find n, p, p hat, and standard deviation of p hat. Now these are all going to help us to be able to use the normal model to calculate our p-value. And so we already said that n is 90. We already said that p is 0.8. And p hat is, now our sample size is 90. So that is our bottom number. Now, how many of the 90 did what we want? And in this case, passed the driver's test, so 61 out of 90. And we can get that as a decimal just for reference, 0.678. And then our standard deviation of p hat is the square root of p times q over n. And I would recommend you keep this. So the one we did in the first video where standard deviation was 0.02, that was an exact answer. It happened to be that 0.02 is the exact standard deviation in the first video. But normally you get an irrational number because you have the square root. Most of the time, you're not going to have a square root that is that nicely. So I say that to say that when you write this square root, you should keep at least 6 digits. And that way that keeps you from having rounding errors. If you cut this off at 0.04, 0.042, then likely when you calculate the p-value, it's going to be off, and off enough that you'll get the problem wrong. So now step 4, and step 4 can vary a little bit if you want to use the z-score or not. So you can use it or not. Some of the problems on the homework will specifically ask for the z-score. But step 4 is to draw the normal curve. And we are going to label p. P is going to go in the middle. That is our mean. And then p hat is going to go wherever it goes, wherever it should go. So p is 0.8 and p hat is 0.678. So we know it's on this side, but I'm going to write 61 over 90 because, again, same way you can have a rounding issue here. If you cut this off, round it off, that can also cause issues. So, and then if you like, you can find the z-score. We won't do that, but you can do that if necessary. Step 5 is calculate the p-value. And we're going to do this using normal CDF. So on the calculator, you go to second bars, pick number 2, and then if you have the menu that comes up after that, then that is helpful. If not, oh, we forgot to shade on this. So on these, I think I said last time, we're always going to shade away from the center. So whichever side you're on, you would shade away from the center. So you're going to shade a small part of this. So on the calculator, when you get to normal CDF, the first number you put in is the lower bound. So that is the left side of this shaded area. So we put 0. The right side of the shaded area. Now you can put 61 divided by 90 in that spot. So you don't have to divide it out and get a decimal. You can just put 61 divided by 90. Then we're going to have our mean, and then we're going to have our standard deviation. You can actually do the same thing. You could, right here, you could type in square root 0.8 times 0.2 over 90 instead of typing that decimal. And then you don't have to worry at all about rounding. So either way. And so we get this as 0.001. Check that real quick, just to double check. Yep, 0.0019. Okay, so that is our p-value. And now step 6, and we're going to talk in a later chapter about what would be considered a small p-value or not. In this chapter, it may state on the homework, it may specify use this as a cutoff, but otherwise, if it doesn't state, we're going to assume that 5% is the cutoff. So, and I usually write these three little statements. I get in step 6, state your conclusion. So in this case, is the p-value small or not? And if we're using 5% as a cutoff, that p-value is small. So the p-value is small, and by that we mean less than 5%. If you go back to the earlier video, page 3, maybe page 2, if the p-value is small, we're going to reject the null hypothesis. And if we are rejecting the null hypothesis, we are accepting the alternative. And if we're accepting the alternative, that must mean there is evidence that p is less than 0.80. So the alternative hypothesis, p is less than 0.80, we're going to accept that as being true. So there is evidence, or at least we're going to accept it as appearing to be true. It could be true. We're going to reject the null hypothesis. We're going to accept there is evidence. Now you're basically just restating the question here. So the question was, is there evidence that teen pass rates are below 80%? Since our p-value is small, there is evidence teen pass rates are below. So we're basically just restating that question. So right spot. There is evidence teen pass rates are below 80%. And that is the answer to the question. And essentially you could, usually these questions are phrased in a way that if the p-value is small, then the answer to the question is yes. Now again, notice, and we talked about this at the end of the last video, small, reject, and there is evidence. So these are all positive statements. There's no nots in here, in other words. So if we got, say, the p-value is 10% or 12%, something above 5%, then we would say p-value is not small. It is not less than 5%. We would fail to reject the null hypothesis, and then we'd say there is not evidence teen pass rates are below 80%. So again, keep all the positive statements in this conclusion together, keep all the negative statements together, and it's all based on the p-value. Is the p-value small or is it not small? I also suggest kind of working your way down this list. So you don't really have to, I mean, you could see this and eventually probably would get to where you don't need to state these first two. You can just say there is evidence, because you know that that's what that means. But while you're learning this, I would suggest that you kind of write these three things out and kind of follow the progression to get down to where you need to come to your conclusion. So, all right, we'll look at two-sided alternatives in the next video.